Welcome to the Total Radiation Solutions RF-EME online training course. This course is designed for people who are exposed in the course of their normal work and under controlled conditions to radio frequency electromagnetic energy, RF-EME. The purpose of this course is to ensure you understand the safe working practices and procedures associated with working in an RF-EME environment. You'll also learn the controls available to manage potential RF hazards. This course is made up of 7 sections. Each section deals with a specific aspect of RF-EME. At the end of this introduction, select Section 1 from the main menu. Once you have entered Section 1, the instructional presentation will commence. At any time during the presentation, you can pause the presentation using the Pause Play buttons. The slider button allows you to move forward and backward within a section, whilst the Back and Next buttons allow you to jump between whole sections. You can also access the main menu page if you need to access another section. There is also a Help button if you require further assistance. At the end of each section, you'll need to complete a small multiple-choice quiz. The quiz helps you check that you have understood the items covered in that section. After each quiz, you can proceed to the next section, regardless of your score. However, if you score below 30%, we recommend you use the Back button to go back over the section to make sure you fully understand what you've been told. When you have finished all 7 sections, you'll need to complete a multiple-choice exam. Click on the Next button to proceed to the first section. Section 1. Electromagnetic fields. In the first section, you will learn about electromagnetic fields, the difference between ionizing and non-ionizing radiation, and some examples of what the radio frequency RF bandwidth is used for. What are electromagnetic fields? As the name suggests, these fields have an electrical and magnetic component. Electric fields are fields of attraction that exist between a positively charged point, such as the terminal on a battery, and a negative one. Electrical fields influence the motion of other electrically charged particles within the field. The units used when indicating the electric field strength is volts per meter, V/M. The flow of electric charges results in the formation of a magnetic field. This field influences the motion of moving electrical charges. The units used when indicating the magnetic field strength is ampere per meter, A/M. What is electromagnetic radiation or energy? Radiation is just a form of energy transfer. Other forms are conduction, for example when heat passes along a metal rod, and convection, for example when heat is transferred using a hairdryer. Electromagnetic radiation, EMR, or energy, EME, is a wave travelling through space made up of electric and magnetic fields. EME waves travel at the speed of light, which is constant at 300 million meters a second. EME can be described in terms of the EME wavelength, the distance between successive crests or troughs of the wave, or the EME frequency, which is the number of waves that pass a given point in a second. Wavelength is measured in meters, and frequency is measured in hertz. If you multiply the frequency and wavelength of any EME wave, the answer is always the same, the speed of light. What is the electromagnetic spectrum? The electromagnetic spectrum is broken up into various sections or bandwidths. You can see from the table that different bandwidths have different properties. For example, visible light with a wavelength of around 300 millionths of a meter becomes invisible ultraviolet light as the wavelength reduces to 3000 millionths of a meter. The EM spectrum is broken up into 2 important categories: ionizing and non-ionizing radiation. Ionizing radiation, or energy, is able to break molecular bonds inside cells. The breaking of these bonds could be the initiator for the development of a cancerous growth. Examples of these types of radiation are X-rays, gamma rays, and cosmic radiation. Non-ionizing radiation energy is unable to break molecular bonds inside cells. Examples include some parts of the ultraviolet UV band, visible light, infrared, RF MW, extremely low frequency ELF, static electricity, and magnetic fields. Radio frequency EME is EME in the frequency range between 3 kHz and 300 GHz. You have now completed section 1. To make sure you have understood the section, you must answer the following multiple choice questions. Please click on the box that you think is the right answer.